students. We are moving to our next chapter, 26, application of calculus. Okay, here we have studied about differentiation. Okay, we have studied the calculus, which means indefinite integral, definite integral, differentiation, differential equations. Okay, like that, all of we have studied. So now we are applying that process, which is in different branches of science, which is economics, accountancy, and commerce, like that. Okay, so in this chapter we have going to apply that things which we have studied in our daily problems. Okay, which is demand and supply, which is related. How will you solve problems like that? And demand and price, supply and price, these are all related to economics and commerce. So we are going to study how this calculus can be used to study these problems, okay, which is related to economics and commerce. Okay, for such as the points we have studying in this chapter are break-even points, which starts a new venture. That means a new venture, which is maximizing profit, minimizing price. What is the elasticity of price, supply, etc. Okay, so that is going to be studied, and we are going to solve problems in this fields. Okay, before that we have to familiarize, we have to understand some concepts and some functions which are related to this. First is functions related to business and economics are the cost function, that is where x denote the quantity produced of a certain commodity at total cost C. So cost means we have, what does the cost refer to? Cost is related to some product always. Okay, we are bought products which having cost. So this function is also which is related to the commodity. Okay, and denote xb the quantity produced by of the commodity of total cost C, and then the cost function is expressed as C, capital C is equal to C of x, cost of that product. Okay, cost of that product, or the quantity of that product produced at the cost C. Okay, then f of cx is equal to 0, which is the implicit form. F of cx is equal to 0. So here the total cost is divided into two main parts. Okay, total cost is divided into two parts, which is the fixed cost and the variable cost. The fixed cost is the company's product, the product of the company is fixed, but from the retailers we have collecting or we have buying that thing which is a variable cost. They can reduce or they can increase that product. That is the fixed cost and the variable cost. Okay, so the fixed cost they do not change with various levels of production. Okay, it does not change. For example, rent, insurance, interest, depreciation, etc. Okay, these terms does not changes, or they does not varies their level of production. Okay, that is, and the variable cost, which is keep on varying the level of production. For example, labor cost, okay, material cost, advertising expenses, etc. Okay, so these things are varying with their production, but these are variable cost. Okay, so thus the fixed cost is independent of x. Okay, it is independent of x because if exchanges, fixed is independent, it did not change, but variable cost change. So variable cost is directly proportional to x, and the fixed cost is independent of x. So total cost is total fixed cost plus total variable cost, that is C is equal to F plus V. F is fixed, V is variable. So C of Fx is equal to, C is equal to C of x is equal to F plus V of x. Okay, C is divided into two, fixed cost and variable cost. So the cost function is C is equal to F plus V of X, which is an example. If the cost production is given by C of X is equal to A plus BX plus CX square, then the fixed cost is C of 0, which is independent. So it is A, and the variable cost is BX plus CX square. Okay, this is, and if another example, C of X is 1 by 3x cube plus 5x square plus 7x plus 5e plus 8, then the fixed cost is 5e plus 8. 5e plus 8 is the fixed cost, x is 0, so 5e plus 8, and the variable, which is the variable, constant is 0, so 1 by 3x cube plus 5x square plus 7x, that is the variable cost. Okay, because it contains the variable, other contains which is independent of the variable. Okay, yes, this is the cost function. And how will you sketch, how will you draw fixed cost, cost curves, fixed and variable cost? That is, the costs are measured along y-axis and the level of output. There should be an output, okay, and that is measured in the x-axis, okay, and the total fixed cost is a curve which is a line parallel to the output axis. That is because the fixed cost remains constant. Fixed cost does not changes, so variable cost changes, which means the fixed cost is parallel to the output axis, and the fixed cost remains constant at 0 and any level of output because it is independent of the level of output. And this is the graph, which is output is on the x-axis and y-axis it is the curve. So TVC, what is TVC? It is total variable cost. Curve begins from the origin, showing that variable is dependent with the level of output. So at 0 level, the variable cost is 0, and then the TVC curve starts from origin. So if the cost is 0, variable cost is 0. So it always starts from origin. So cost function graph starts from origin and it increases. As the producer begin to produce output, they have producing output, so he have to spend some variable factors. In a industry or in a company, okay, various product have been, that is the output. If we have producing a shampoo, that is the output. So there are labor, raw materials, transport, fuel, etc. are there. So that cost must be variable. So the increase of output increases TVC. That is the given here. So the curve is an S-shaped curve, we can say, because the variable the law of variable productions may be changing. Okay, that is, so this is the curve. Okay, and that is given here, the inverse S shape, that this short run TC is explained by the law of diminishing returns in production. Law of diminishing returns, if you have studied in commerce, you will know about that. Okay, right, see, the total cost is the same shape as the total variable cost. Okay, and next is the demand function. So cost function, demand function. Demand is particular for a commodity, depends upon the number of factors. How so many factors are related here, depends on here. That is, what is the taste of the consumer, because the consumer needed to buy the product. So the taste of the consumer, quality of the product, price of the product, disposable income and wealth, etc. These all are depends on the demand of that product. So the facilitates study of the demand function. All factors other than the price are taken to be as constant. Okay, that is, the demand for a product is considered to be dependent on its price only. So the demand is depend on the price only. Demand function is said to represent the functional relationship between demand and price of a commodity. So demand function is the demand and the relationship between the demand and the price of a commodity. So what is the demand function is? If P denote the price per unit and X is the number of units demanded by a consumer at that price, then the demand function is X is equal to F of P. That is, F of XP is equal to 0. Okay, so that is the demand function. Okay, so the curve is also given there, which is on the P axis and X axis is here. P axis is the price per unit axis, x-axis is the number of units demanded there. So the quantity demanded, the price per unit is, it is an inverse. Okay, so this is the curve. So in demand function, x is equal to f of p. X is the dependent variable, p is the independent variable. So x greater than or equal to 0, p greater than or equal to 0, because negative quantities and negative price are meaningless. So demand and quantity should be positive. So the value x and p are always positive. So there is no negative case here. Okay, and then price increases, demand decreases. As price increases, demand decreases, and price decreases, demand increases, as you know. Okay, if the price of a thing is high, the demand is less, but the price is low, the demand is very high. Okay, that's there. So the demand curve is always a decreasing one. It is from the top to bottom. Okay, it is a decreasing one. And next is the revenue function. What does the revenue function means? So you know what is a revenue. It is the amount of money received from the sales of a goods. A good is sold, and that amount of money is the revenue. And it is depend upon what? It is depend upon the selling price of the product and the actual quantity sold. So the price and the quantity sold, that is related. These two things are depend. So the total revenue is quality sold into selling price per unit of the commodity. Okay, that is, if R is the total revenue collected by the seller on selling X unit of commodity, what is the price? At price P per second. P per unit. So that R is P into X. P is the price per unit and X is the unit of the commodity sold. Okay, so the revenue function is R is equal to R of X. Function should be always there should be a variable there. So R of X is Px. So the demand function, by demand function, the price per unit P may be expressed as a function. So P can be expressed as a function of X. So it is G of X. Then R is P into G, Px, which is X into G of X. So revenue function is R of X is equal to X into G of X. G of X is P, which is the price per unit. Okay, that is revenue function. Next is the profit function. Okay, so that is here. Okay, next is the profit function. So profit, you have know what is a profit. Total revenue minus total cost. Profit is what we have get. Okay, after selling and after cost means after production and selling, what remains for us, that is the profit. So profit is total revenue minus total cost. So P of X, which is R of X minus C of X, that is the profit. Okay, yes. Next is the break-even point. So the break-even point is that point where total revenue equals total cost incurred. Okay, the total revenue and total cost if equal, then it is the break-even point. That is, it is the point at which a company begins to earn profit. So if the total cost and total revenue is equal, that is the cost of production and the amount we get after selling that product is equal, we earn product. That is the break-even point. So it is a point of no profit, no loss. There is no loss and there is no profit. So that breaking point, profit is 0 and there is no loss also. Okay, so we know that profit is P of X is equal to total revenue R of X minus C of X. X greater than 0, and at even break-even point P of X is 0, that is Rx is equal to C of X. Okay, so that is break-even point means there is no profit, there is no loss. The total revenue equal to total cost. Okay, that is. So graphically we can say there is a intersection between the profit, total revenue graph and the cost graph. So cost is in the cost is in the y-axis and revenue is in the x-axis, then we can say the rx line is that line, and profit area is here. So cx line is here. So the loss area and profit area is there. Loss area is below and profit area is above that. So that intersection is the break-even point. If they intersects, it is the break-even point. Graphically it is given. Okay, and there is the problem. If a company produced, so these things you should have to know, then you can apply this this type function and this concepts to the problems. So a company produced a commodity with rupees 20,000, fixed cost is given, variable cost is estimated to 35% of the total revenue. Okay, when it's sold at a rate of rupees 6 per unit. So find the total revenue, total cost, profit function of the revenue when it is sold. So let us take X be the unit of produced, and the fixed cost is given, and revenue is 6x because X is the number of unit. What is the variable cost? Which is 35% of the total revenue. That is 35 by 100 into 6x. So it is 21x by 10. So the variable cost is get. So what is the total cost? Variable cost plus fixed cost. So 6x plus 20,000 plus 21x by 10. So you will get the answer. Then profit, you have to find the profit also. R of x minus C of x. R of x is given, C of x is given. Find the answer. Okay, now need to simplify it. Okay, yes. Similarly, here is the problems for that. Okay, so like this, you have to solve these type of problems. Okay. Okay. Next is the average fixed